circuit, you can create a new circuit. I'll go for a standard one with a good connection on there, so at least I know I have connection for both the positive and the ground. So we can zoom in and zoom out, and we need an RGB according to the question. Drag and drop. We can drop it here, and from last week we recognized that we need a connection between each line and the ground. So this is the common cathode. Some people just connect, which is a cleaner way of doing it, but I'm going to go the long way. Some people just connect a resistor in there between the RGB and the ground. Let me make it large. But we are just going to use the standard connection. So we're going to connect a resistor from each of them. Do it, by all means, please connect it the way that you want it. So I'll get for resistors. And the resistor value from last week, we understand that the internal current is 20 milliamperes. So if you have 5 volt divided by 20 milliamperes, give you gives you about 110, but by using 220 ohms, it's a safe resistance to use. So we won't blow up any circuit. And if you hover over it, we notice this is the red LED, and we are using A0 for the red LED. So I can go all the way there. No idea, but let's try to A0 and give it the red LED. In the same way, I can leave the cathode or just connect the cathode to ground. Can copy the resistor. Or 220, and this is our blue pin. So blue pin go to A1. It doesn't matter how you connect it. What matters is how you program it in terms of pin. But you should make sure they are connected to the analog pins, which is the A1. So this was blue. Blue, where are you? Blue. And I can finally connect the last one. It's fun connections I've got today. To A1, and that is obviously our green connection. Good. So to code it, you've got a bit of writing to do. You click on the code. We don't want this. We want the text programming, and you continue to text, and you can start coding on there. I've given you the skeleton to write on. So you have the skeleton code on the side for you. So we can start digging in. We know the pins, we see which pins are connected to what. Let's get back to this later. So I'll use constant. We can talk about constants later because I don't expect them to change. So yes, let's call this red LED. And that was, I think my red was A0. So if I enlarge this, my red LED was A0, blue was A1, and then green was A2. So you make sure you connect to the right pins. Let's make it fun. Like I said, you name it any way you want, but it should reflect the code you're writing. You can worry about formatting and other things later as you go. So because we are using these LEDs, we should declare these pins, we should declare the pins as output because an LED is an output. So you've got the pin as an output, and then you make sure the names correspond. And then we have a function for us that executes, but we don't want to go through all these functions now because I want to show you something on this side. So obviously you can't go through the functions as you want, but I can use a for loop, for example. And your goal is to execute something similar on the side or make use of what is on the side. In steps of 5, that works, and we put a loop. Let's make a very poor code, but it will serve our purpose. Yeah, thanks for spotting that. Yeah, well spotted. I'm glad you're following. That's awesome. It's a very crude way of programming it, but it works anyway. So let's see. Well, hopefully it works. And we will put analog right. Not correct, one message. I'm getting some messages. I'm going to read through the messages as we check this for errors. Hopefully, not much. We fix the errors as we go. So what were the questions? Oh, I equals 0 stuff. We will fix it as we go. Thank you. It's complaining too few arguments for what? I'll be surprised if we miss, but it was complaining. Now it's running. I missed something. Yep, so the little thing I created, obviously I missed the close brace. I have to trace back. Trace circling through different colors of different values. Like I said, this is not the most optimal way to program it, but different color combinations, it means it's doing something just to get you going. So those who said red is not working, you do see the red there, but that's just because in the loop I had before, the Z will be running faster. So actually the other colors were running faster before it was the green. So we'll start with the green and then obviously alter by mixing the blue way before it mixes the red. But if we turn it around where Z is running faster, you see that the red is running first. So we are in, we've basically just, yeah, basically it is 3D matrix. That's why I said it's inefficient. It's just playing around for people to see what can be working. So it's well spotted, man. We've come to the end of the session for today. I will leave the tasks. You've got quite a few tasks for you to play with.